Tomorrow. Girl, bye. Okay. So, it's actually tomorrow and Friday already. Okay, so take your purple sheets.
I think I'm going to be sick for those days. I'm going to be sick for the next 5 months.
I mean, you were supposed to do it over the 4 days that you had it already.
I didn't even have 4 days.
Okay, fold it in half again.
I woke up early. All 4 days.
Okay, then,
You fold it in half first.
so fold it in half.
Hamburger style.
Hamburger. Then, mini burger slider. Okay, now listen.
Spin the block every night.
I'm going to send you a picture and a video of your review. If you don't make your cheat sheet, study sheet, whatever you want to call it, you will not have one tomorrow. So I will send you the video if you want to hear it explained, and then I will also just send you a picture of each side. If you don't want to watch the video, you just want to have access to it, you copy it. Yeah?
Yeah.
You have your paper, put it to the side, let's do the review. So, front page, pick a few.
Pick the hardest one.
Okay, you tried it over the weekend already? Yes?
Now,
You baddies. Okay. Yeah, what would you do? 4 whole days.
It's some
Yeah.
Good afternoon, teachers. We will do a quick check for ID badges, make sure everybody.
Ain't nobody got time for that.
like we get it.
Also, one of the students.
We get it. Thank you. Yes.
Berkner Buck. Steve Berkner Buck.
I had to cut them out.
Wearing your ID badge, or sports thing.
I cut those out. This is my second year.
Okay.
I'm gonna sell them to people. Yeah,
So
but
if you have any, you want to make
it's just a
sure
little
you,
steal.
No stealing Berkner bucks.
Start cutting.
I do.
stealing them? You want to give us some? You want to answer a question?
Maybe.
Yeah.
Whose review isn't blank? Anyone?
I'm on it. I don't know about that.
You did those right now. No. Okay. The review is on my desk if you on that black shelf if you need it. Okay. So look at the front. You want to pick a couple? Which ones? Let's go. 5. Sounds good. Okay, focus so we can use our class period really wisely. Okay, number 5. You got to rewrite it. What do you rewrite? Okay, good. That is x to the 2/3 plus 2. Okay? Now, notice I still have to take the integral of that, right? I only rewrote it. So, when I add 1, I need to really add 3/3, because that's what 1 is. So, add 3/3, what do I get? X to the 5/3, but then if I have to divide by 5/3, that's a what in the front? 3/5 plus antiderivative of 2 is plus, remember that is a general, you don't have to write this, but a general solution. Okay, a particular solution is when you find C. Okay, number 7, no product rule. You got to combine those terms. How do you what do you do with the exponents when you multiply the bases? You add the exponent. So when you do y to the 3 times y square rooted, that's really y to the half, you have to add those. Right? That's how you multiply. You add the exponents. So if I do 3 plus a half, what is that as an exponent? Okay, 3.5, which would be 7 halves. Yeah, was what I was looking for. I guess you could do 3.5 if you wanted, but probably harder. Okay, so add 1 to 7 halves, so I'd be adding 2 halves. What is 7 halves plus 2 halves? Y to the 9 halves, and then what do I put in the front? Plus C. Okay? With the adding part?
With the 7 halves.
Okay, so what I would do, guys, if you need help with that, think about if I'm adding 3, how many halves is that? 3 is the same as 6 halves, and then I'm adding 1 more half, so I'd get y to the 7 halves. Does that make sense? So you have to turn everything into halves. The way that you procedurally do that is that's like a 3/1. You'd multiply by 2 on top and on bottom. That's where the 6/2 comes from. Okay? Yeah? 2/2 is just the same as 1. So remember your rule. You add 1 and then you divide by that. So if I do 7 halves, I added 1 to get 9 halves, and then divide by 2/9. So this is your actual rewrite. The added 2 is part of the rule. Okay, do we want to do one more like that? Is there another one like, oh, we just did both of them.
13. We have 13.
Sure, yeah? You are multiplying by the reciprocal because you're dividing by a fraction, correct. Okay? All right, come down to number 13. Okay, number 13, you're going to, remember, no product rule. So what do? I distribute. What is secant theta times tan theta? Secant theta tan theta plus, what is secant theta times secant theta again? Secant squared theta d theta. Now there is an error on that. It says dy. It should say d theta. That letter should match. So if you want to go ahead and change that, you can. Okay, now from here, what do? Power rule, wrong. You look at your sheet. Okay, I want the integral of secant tan. What's the integral of secant tan? Integral of secant tan is regular secant. What's the integral of secant squared? Regular tan. Okay, so it'd be secant theta plus tan theta plus c.
What if we don't have to do stuff?
I have extras, and I can give you one today.
Are they going to have questions like that from the AP exam?
Yes,
And we don't get our yellow?
correct. So closer to the AP test, I'd memorize it. Right now, I wouldn't worry about memorizing it. But by May 5th or whatever that date is, you would have to have it memorized. Now, the other thing I'd say, too, is remember, you're really getting like double the bang for your buck. Because what's the derivative of tan? Then what's the integral of secant squared? Tan. What's the derivative of secant? Secant tan. What's the integral of secant tan? Secant. So they're really the same rules, just backwards of each other. Okay? Anything else on this front sheet? The only other one I can kind of see maybe people getting wrong is look at number 2. And then we're going to turn the page. And actually, hold on. What's the integral of 8? Okay, integral of 3 is, don't overthink that. Okay, just be 3x plus c. Okay? All right, come up to number 2, last one. Simplify that. What would that be the same as for my rewrite?
I don't have to actually think of 3.
Okay, is this right? Okay, can it be this? Okay, let's talk PEMDAS. When I apply the exponent, it goes to everyone in the parentheses. So I have to cube both the 2 and the x. So this is really 1 over 8x cubed. And then can I pull the 8 up with the x? So this is then the same as 1/8 x to the negative 3. Okay, be very careful about when I cube or apply the exponent, everyone gets it, but only the x can move up with a negative exponent. 8 stays on the bottom. So let's do our rule. I have to add 1 here. What's negative 3 plus 1? X to the negative 2, but then I have to divide by negative 2. So that's like a negative 1/2, but I already had an 8. Then what is it in the front now? You're just multiplying these. Negative 1 over 16. Very good. And then x to the negative 2 plus c. Now, if this were multiple choice, where would that x to the negative 2 go? Back on the bottom with the x. So I'm going to put here, or negative 1 over 16x squared plus c. Okay, but the first option is fine, but if it's multiple choice, they wouldn't leave it like that. Are we good to turn the page? Okay. Good, good, good. All right, next four, pick one. We'll just do one of them. Which one? 30, okay. You have second derivative is 3 sine x. Integrate both sides. If I do an antiderivative on the second derivative, what do I still get? The first derivative, which would be dy dx. Okay, remember, snow cone, snow cone. If I'm on sine and I go up from the top of the list, where do I end up? Negative cosine, oops, put your 3 still in the front, plus c. Okay, then which of these conditions do I use, first or second? Dy dx goes with the f prime statement. So f prime of 0 is 5. What's cosine 0? 1. 1 times negative 3 means the negative 3 stays. Negative 3 plus c. To solve, I have to add the 3 across, so c is how much? 8. So come back up here, I'm going to put dy dx equals negative 3 cosine x plus 8. Could you also just slash the c and plug the 8 in? Sure. Some of y'all missed points on your quiz, though, because you didn't rewrite it.
Wait, so you can just like erase it?
You could even do this. That would be fine. As long as you remember to do one or the other. Okay? On the AP test, as long as you clearly slashed out, put the number in, it's totally fine. Okay, integrate again. We got to get back to regular y. Antiderivative of dy dx is regular y. What's the antiderivative of negative 3 cosine? Negative 3 sine x. What's the antiderivative of plus 8? 8x plus c. And then I would move to my second condition. F of 0 is 10. That means 10 is the answer when I plug in 0. Well, sine of 0 is 0, 8 times 0 is 0, so c is 10. So remember, two options, either slash this out and put a 10 or rewrite. Okay, what is that called? Your particular solution. Okay, you don't have to write that, but just remember the difference. Also, do you remember what a differential equation means? It just means your equation is for a derivative. So don't get confused by that. Okay, 31's particle motion. I feel like we've done a gajillion of those. You had one on your quiz last week. Do we need to go over it, or can we skip and come back if we have time? Skip? Okay, turn the page. I really want to try to get through at least a couple of the FRQs. This is one of them. But first, I want to do the very last FRQ. Joanna jogs, this one right here. We did. Do you need it? Okay, it's right over there on the black shelf right behind my desk. Okay, so it says, Joanna jogs on a path, her velocity is given by a differential equation, blah, 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 v of t is in the table. Okay, it's measured in minutes and meters per minute. Part A says, find v prime at 16. V prime is a slope. What type of slope am I going to have to find if they gave me a table? A rock. Okay, here's why. Do you have an equation to take a derivative? No. Then that means average rate of change. Now also put a star on this. There's one almost exactly like this on one of the parts of your test. So if I have velocity and they ask me for v prime, they're asking me for the slope. Where does 16 fit most conveniently? Okay, 12 to 20. So for part A, I'm just going to do it up here in the corner. Okay, I would do v of 20 minus v of 12 over 20 minus 12. What's v of 20? 240 minus, what's V of 200? Okay, then over? 8. Now, can you leave your calculation like that? Sure. But 240 minus 20 is 40. What's 40 divided by 8? 5, right? Okay, now let's talk about units. Okay, if this is meters per minute and I took the derivative or the slope, meters per minute squared. What else could they have called that besides V prime? Acceleration at 16, okay? All right, go to part B. Explain the meaning of the integral of the absolute value of V of t. What does that tell you when you integrate the absolute value of V of t? What? Distance. What if they took the bars off? What would it have been? Displacement. Okay, that will be on your cheat sheet tomorrow, but you should know the difference. So the integral from 0 to 40 of the absolute value of V of t dt represents the total number of what? If it was meters per minute and I integrated, what would I get? Meters. Traveled by who? Joanna over what time period? And then that is measured in minutes. Very good. Okay, the integral of the absolute value of velocity is the number of meters traveled, or you could have said the total distance in meters traveled. Just make sure you put units. Okay, then it says approximate using a right Riemann sum. Which one is going to get skipped if I do a right Riemann sum? 0. So that guy's not going to count. Everybody else is going to count. Do I have the same delta x each time, or is it changing? Changing. So my approximation from 0 to 12, what's my delta x? What is my right side y value? Plus. From 12 to 20, what's my delta x? What's my right side y value? From 20 to 24, how wide? What is my right side y value after I take the absolute value? 220. Okay, but make sure, why is it positive? Because I'm integrating absolute value of velocity. Okay, and then last one from 24 to 40, that'd be a 16 width, and then a 150. Okay, you do not have to add them up. Okay, part C. Okay, so Joanna's jogging, Bob is riding his bicycle. For 0 to 10, his velocity is modeled by this. Now, they called it B for Bob, but I'm going to write next to it. That's his velocity. Then it says to find his acceleration. How do you find acceleration if you have velocity? Take the derivative. So I'm going to put B of t is t cubed minus 6t squared plus 300. That's his velocity. Well, then if I want his acceleration, I want b prime of t, right? So they picked a different letter other than v, but that's okay. If b is velocity, b prime is acceleration. So what would the derivative be?
3t squared.
Yep, minus?
18t squared.
Close, you're multiplying the 2, yeah. And then what about the plus 300 for a derivative? 0. Okay, then that's his acceleration at any time. When do I want his acceleration? At 5. Notice I'm labeling as I go. Once I plug it in, do I have to finish out the math part? No. Can if you want to. It's not hard, right? 5 squared is 25 times 3 is 75. And then we're taking away 60. Now, if this is his acceleration, what are his units? Meters per minute squared. Make sense? Okay, so now go back to that graph question we skipped. Good to take this off? Alright, so we're gonna start now here. Okay, what is this a graph of? Okay, this is an acceleration graph. Okay, most of the examples we have done in class, what graph have we had? Velocity. So this is not a velocity graph, this is an acceleration graph. So part A says, is the velocity of the car increasing at 2? Okay, well question, is this a graph of velocity? No, this is a graph of acceleration. What is the acceleration of the car at 2 using this graph? Now question, normally acceleration's the slope. But if this is acceleration, do I want the slope? I just want the y value. So at 2, what's the acceleration? 15. Okay, that's the y value on the a of t graph. Okay, now think about, if the acceleration is 2, at 2 is 15, then is the velocity increasing or decreasing? Increasing because why? Because acceleration is positive. Very good. So I'm going to put then velocity is increasing since a of 2 is greater than 0. Remember, acceleration is velocity slope. So if acceleration is positive 15, then velocity slope is positive, which means velocity is increasing. Okay, part B. For what interval of time is the velocity decreasing? Okay, well think about, if velocity is decreasing, then its slope needs to be negative. What is velocity's slope called? Acceleration needs to be negative. So if velocity is decreasing, its slope is negative, its slope is this graph, acceleration. When is acceleration negative? When it's where? Below the x-axis from 6 to 16. Very good. And then I'd put because acceleration less than 0. Now, if this were a velocity graph, I'd be looking at the slope, right? But this is already acceleration. Okay, next point, part C. Find the car's velocity at 6 seconds. What is this a graph of? Acceleration. How do I get from acceleration back to velocity? Antiderivative. So this is what you're going to do. You're going to make a little chart. And we're going to have to find what the car's velocity was at the beginning. They tell you that in the question. A car is traveling on a straight road with what?
55.
Velocity of 55 at time 0. Now remember, when you don't have to write this, but just look. When I integrate acceleration, that tells how much the velocity changed, right? When I integrate velocity, it tells me how much the position changed. Then when I integrate acceleration, it tells me how much the velocity changed. So at 6 seconds, what shape did I accumulate in the graph? A trapezoid. We know how to find the area of a trapezoid. 1/2 base 1 plus base 2 times height. What's my base 1, the bottom one? 6 plus, what's my top base? 2, so 1/2 6 plus 2 multiplied by a height of 15. 6 plus 2 is 8. What's half of 8? What's 4 times 15? 60. Now, did the velocity, which started at 55, go up 60 or down 60? Up, because where's the area? Above the x-axis. So I'm going to put here plus 60. What is the velocity then at 6 seconds? 1:15, right? So I would say at 6 seconds, the velocity would have to be 115 And then that's measured in feet per second. Okay, next part asks me for the absolute max velocity. Okay, well, that means we need to put the other critical number and the endpoints in our chart. What's the other critical number besides 6? 16, and then what's the endpoint? 18. Okay, from 6 to 16, what shape did I accumulate? Another trapezoid. Okay, we'll do this one here. Okay, but we need to know how big it is, and am I going to add it or subtract it? Because the area is where? Below. So I'll do 1/2. My base 1 here from 10 to 14 is going to be 4 across. And then my base on the x-axis from 6 to 16 is 10. And then my height is 15. So 1/2 of 14 would be 7. What's 7 times 15? 105? Okay, but do I add or subtract it in my table?
Subtract.
Okay, so minus 105 from 115. What's his velocity? 10. So put a 10 right there. Then my last one from 16 to 18. What shape did I accumulate? Okay, triangle. We need to know how big it is. So we'll do 1/2. My bottom base is 2. My height is 15. 1/2 and the 2 basically just cross out, so it's a total of. So if I add 15 to 10, what's his final velocity? 25. Make sense? Out of the chart, what is the maximum velocity? When does it happen? At 6. So I would say absolute max velocity is 115 feet per second at t equals 6 seconds. Now, it says to justify as long as my table is labeled appropriately, which it is. Okay, that counts as my justification. Okay, next part. At what time other than 0 is the velocity of the car 55? Okay, and then why? Look at your chart. I started at 55. Am I going to hit 55 again?
No.
18.
I don't know why.
Okay, so I went from 55 to 115, then back down to 10. Did I have to hit 55 between 115 and 10? Yes. Now, it doesn't say does it, it says at what time. So come up here to your graph. Okay, I want you to think about, I want him to get back to 55. So, all of this area up here shows how much his speed went up, right? When does the amount of speed that he went down equal the amount of speed that he went up? At 12. Okay, I want you to think about why. This is how much he increased. That's where he sped up. This is how much he slowed down. If how much he sped up and how much he slowed down are exactly the same, then what's his velocity going to be back at? Well, his velocity will be back at 55 again. Does that make sense?
Because that's where it starts.
Because that's exactly where his starting velocity was. Now, where did we say that happens? What time? 12. So, let's explain that. So, I'm going to put t equals 12 because, and this is how I'm going to explain it. You could put it in your own words however you want. The integral 0 to 12, v of t dt equals 0 because the area above and below the x-axis cancel, meaning net change in velocity is 0. So basically I'm saying that how much it went up cancels out how much when it went down, then my displacement or my net change for how fast the car is going is 0, then it's back at the same speed. Okay? Okay, but could you explain that in different words? Absolutely. Okay? Last one. Did the car's velocity ever equal 0? Well, what was the absolute min in the table? 10. Then did it ever get to 0? No. So I would put none. Absolute min velocity is 10. So it never has velocity of 0. Okay, the lowest it ever gets is 10. There's never enough area below to cancel out all the area above. Good? Good to turn the page? Okay, take a look at the next 2 pages. You want to do the other FRQ, or do you want to do the Riemann sum one? Ops. Am I good to turn this page? Okay, so we can either practice the Riemann sums, or maybe we just practice like 1 or 2 of them. Make sure you got it. Okay, let's do the right Riemann sum. Okay, we're doing the first 12 seconds. So I'd go integral 0 to 12. It says distance traveled. What do I do for distance traveled? Velocity or absolute value velocity? Absolute value velocity. Approximated by, because it's not going to be perfect. The first jump in my chart is from 0 to 3. What delta x is that? 3. And then I want the right side.
22.
Plus 3 to 5. Distance of 2, right side.
29.
From 5 to 9, how wide is that?
4.
Right side y value.
38.
And then last one from 9 to 12. Distance of 3, right side is. Now, why am I stopping there? Because it only asks for the first 12 seconds. Okay, then it says, is my approximation an under or an overestimate? There are 2 things you have to consider. Not just the left or right, but which way your function's going. Look at your graph. 20, 22, 29, 38, 42. Is it increasing or decreasing? Okay, it's increasing. And if it's an increasing graph, there's your picture. Okay, splice it up. Pick the right side. Is it too big or too small? That is too much area. So I would just explain that. So I would say this is an overestimate because, and then you have to say 2 things. That you noticed which way it was going. Okay, so I'm going to put V of t is increasing. And so, the right y value is the biggest on each subinterval. I'm just going to put each interval. Okay, but what you're saying is, since my function's increasing, my right side's always the biggest on that chunk of the graph. Now, what if I had used the left side? Would have been an underestimate. Okay? Alright, jump down to the trapezoidal rule. Make sure we remember how to do that. Do you remember how to do the midpoint? We want to do it? Okay, remember for a midpoint, you have to remember to skip 1 in the middle. So for example, if I'm doing this next part, I want the first 20 seconds. So I'll go 0 to 20. V of t dt in absolute value bars. Approximated by, just like that. Okay, for a trapezoid, or for a midpoint, I have to skip 1. So I'm not going 0 to 3. Let me come out to my graph here for a sec. I'm going to go, we'll do it in orange. Okay, I'm going to go from 0 to 5, and then what's my y value? 22. So I'll do 5 times 22 plus, just like that. Okay, then from 5, I'm going to skip 9 and stop where? Okay, from 5, I'm going to skip and go to 12. My middle y value is 38. Now, 5 to 12, how wide is that? 7, so it'd be 7 times 38. And then last one, I'd go from 12 to 20. How wide is that? 8. And what's my middle y value? 49. Got it? Then you don't have to add them up. Remember, midpoint, you can't tell me if it's above or below, so I won't ask. Okay, last one, trapezoidal rule. Ask me to approximate the integral 0 to 20 of v of t dt. Oops. Okay, can we do the short formula or we have to do the long formula? Long. Okay, because why? The delta x's aren't always the same. So remember, I'm going to do 1/2. What are my first two y values for me to add up? 20 and 22, and then what's their delta x? 3 plus. Then 1/2. I repeat 22 as a y value, but now it's partnered with 29. And then, I'm going to come up here just for 1 second. If I'm using 22 and 29, what is the delta x between 3 and 5 again? Back to 2. Make sense? So you're doing 1/2, then you're reusing 29 added with what's the next y value? 38. And then what's the y value between their x's? 4. 1/2. My next one will be 38 plus what? 42. And then 38 and 42's x's are 9 and 12. That's a delta x of 3. Next one is 1/2 42 plus the next y value, which is 49. 42 and 49's x's are 12 and 15, which is a delta x of 3. And then what's my last one? And then a distance of 5. Very good. Now, if it asks you to interpret and you're integrating velocity with no bars, what? Displacement. Very good. So if it says interpret, okay, I would say integral represents the displacement of, what is this, the velocity of? Okay, of the rocket. Now, what would it be measured in if it was meters per second? In meters. Over what time period? 0 to 20 seconds. So if I were to add all this crap up, it would tell me the number of meters that the rocket is displaced. Why should I not say distance traveled by the rocket? No absolute value bars. Good job. Good job. So I have a couple more minutes. We want to do one more? Gonna pick? Oh, how would you do part A? How do I find acceleration if I have velocity? Okay, I want to take the derivative, but I don't have an equation. A rock. Remember? If this is velocity, and I want average acceleration, that's a rock. Then if it says first 12 seconds, that would be 0 to 12. So you do v of 12 minus v of 0 over 12 minus 0. 12 is given to be a velocity of 42. Velocity at 0 is 20. 12 minus 0 is 12. Top of that would be 22 over 12. I'm not even going to reduce it. Include units. What is the slope of meters per second? Meters per second squared. And again, reduce it if you want to, but you don't have to. Okay, if you guys need help, I'll come in early tomorrow for tutoring before school if you guys want. So just message me, let me know if you think that you're going to need help. Okay, you can do it.